Let's go ahead and take a look at some of our homework problems from chapter 7.3, circles. Hopefully you guys are doing okay with this, but let's go ahead and just take a look at a few problems in case you're having trouble. The first section tells you to write an equation for each circle if the coordinates of the center and length of the radius are given. So in number 17, they give you a center of -1, -5, and they give you a radius of -2. Oops, sorry, not -2, +2. And so before we do anything, let's go ahead and get the general form of the circle. The general form of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where the center of the circle is opposite of h, opposite of k. Because remember, when things are happening inside parentheses or inside grouping symbols, the movement, the shiftage, is going to be opposite your intuition, and where r is equal to the radius. Now notice I did not put r squared because r squared is the radius being squared. So let's go ahead and put this circle into general form. Remember, opposite your intuition, so it's going to be x plus 1 quantity squared, right, because it's opposite of -1, plus y plus 5 quantity squared equals, well, r is 2, but remember I need an r squared here, so that's going to equal 4. And that's how you do the first one. I'm going to jump over to 21. You guys are responsible for 19, but I'm going to skip it. I think you guys can handle it. If the center is 0.5, 0.7, and the radius is 13.5 units, again, just pump it into your general form. So that's going to be x minus 0.5 quantity squared, because it's positive 0.5, so we're going to go opposite our intuition, plus y minus 0.7 quantity squared equals 13.5 squared, that is 182.25 units. And that's as far as you go with this problem. The next set of instructions tells you to find the coordinates of the center and the radius of each circle whose equation is given. Then draw the graph. So let's take a look at some of the more difficult problems in this section. Let's go ahead and take a look at number, say, 25. They give you something that looks like this. X minus 3 quantity squared plus y minus 1 quantity squared equals 25. So let's identify the center. The center, remember, is opposite your intuition, so if it was negative on the inside, it's going to be positive on the outside. -1 will give me a positive 1 for my center. My radius is the square root of 25. Well, that is 5. So go ahead and just graph this thing. It's centered at 3, 1, 1, 2, 3, up 1. And let's go ahead and just draw the circle. So 1, 2, 3, 4. The radius is 5, which means that from my center, I'm going to travel out 5 in each direction. So 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, more or less, your circle, whoa, should look like that, more or less. Let's go with 29. That is going to be the quantity x plus rad 5 quantity squared plus y squared minus 8y equals 9. Okay, a couple of things about this problem. One, we've got a more difficult shiftage here. We're going to the left rad 5 times. But here, this y squared isn't quite in its standard, in its vertex form yet. Or the general form, I apologize. It's not quite in the general form, so in order to get it into general form, remember back from the lecture, we have to use completing the square. Now I'm going to use completing the square only on the y side, so x is going to get left alone. And I'm going to pull y squared minus 8y. I'm going to leave myself some space, and I'm going to add this 9. Like all completing the square problems, I'm going to add the box. On the other side of the equal sign, I'm going to add the box, and that's going to be squared. Inside the box goes a -4. Now, unlike the parabola, there's nothing on the outside here for it to interact with, so this -4 is going to be fine on its own. The easy side is going to be x plus rad 5 quantity squared plus I've got y negative 4, so it's y minus 4 squared equals, this is 16. 16 plus 9 is 25. So that means that my center of this problem is going to be negative rad 5 comma positive 4, and my radius is equal to 5. So let's go and draw that. Rad 5 is just a little bit bigger than 2, so it's about 2.1. Okay, negative rad 5, that's negative 2 in a little bit, and then up 4. And so now from here I'm going to travel out 5 in each direction. So 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5. To the right 1, 2, 3, 4, 5. And then down 1, 2, 3, 4, 5. Okay, more or less a circle, but it looks a little bit more elliptical or ovular to me, but that's because of the lack of precision with drawing. Let's do a harder one that requires us to do completing the square a couple of times in the same problem. Those problems are actually kind of cool. A problem like number 39. An excellent problem. X squared plus y squared plus 2x plus 4y equals 9. First thing I'm going to do with this problem is I'm going to rearrange everything. I want all my x's together, and I want all of my y's together. Now, notice, I left myself some space, and I want you to do the same. Okay, completing the square is going to happen twice in this problem. Let me break out with the ketchup. I'm going to add the box squared. I'm going to add, once again, the box on the y side, which means that the 9 is going to get a blue box from the y side, and it is also going to get a red box from the x side. In the red box, half the middle term goes, so that's going to be 1. In the blue box, half the middle term goes, so that's going to be 2. And that's going to get added to the other sides as well. So let's go ahead and simplify the easy side. The easy side is going to simplify, the x's are going to simplify to x plus 1 quantity squared, plus, right, that's where this came from, the y sides are going to cancel, or simplify rather, y plus 2 quantity squared equals the hard side. This is 1, this is 4, 9 plus 4 is 13, 14. And so now our center is going to be at negative 1, negative 2, and that came from these coordinates here, opposite intuition, opposite intuition. The radius is going to be square root of 14, which is kind of like 4 but a little less, so I'll say 3.7. Why not? Okay, let's go ahead and draw this out. Center's at negative 1, negative 2, so that's down here. 3.7, so 1, 2, 3, and a little bit more. 1, 2, 3, and a little bit more. 1, 2, 3, and a little bit more. And then back down 1, 2, 3, and a little bit more. So the only real caveat with this problem is making sure you do completing the square twice. Right? Completing the square here, and then completing the square here. Sorry, completing the square on the y's, completing the square on the x's. Make sure you keep that straight. Okay. Let's take a look at some harder problems here. Number 45. Okay, number 47 here is a bit of an odd problem. It's asking you to write the equation of the equation faux a circle, the equation of a circle that has a center at negative rad 13, comma 42 and passes the origin. And we all know the origin coordinates are 0, 0. So what they're basically looking for is something that does this. This is, I'll call this negative rad 13, and then 42 is going to be way up here, right? And what they want this circle to do is they want this circle, it's going to pass through the origin, which means it's going to do something that looks a little better than that. Okay, this is the point you are looking for. Right? Now, this point here is important because the origin we know is 0, 0. So what I have is I have a circle that passes through 2 points, and oops, this is the center. Sorry, I drew the circle incorrectly. The center, it is not supposed to be this. The circle is really doing something that looks kind of like that, with the center in the middle. What this circle is doing is I need to find the distance between the radius and this point right here, or the center and this point. That's going to give me the radius. The radius is going to be found using the distance formula. So that is going to be, call this x sub 1, y sub 1, x sub 2, y sub 2. So what I have is negative rad 13 minus 0 squared plus 42 plus 0 quantity squared. So this is 13 plus 42 squared. So it looks like 42 squared is 1464. That's a big number. So if I add that to 13, I'm going to get 1477. And I realized I just made a mistake right there. That's not 1464, it's 1764. So the actual radius is going to be the square root of 1777. So now that we have a center here, we can write the equation of this circle. So that's going to be x plus rad 13 quantity squared plus y minus 42 quantity squared equals rad 1777 squared is 1777. And that's as far as you need to go with this problem. 47 is a similar problem. It's telling you a circle is tangent to the y-axis and has a center at -8, -7. Let me pause and type that down real quick. Okay, we finally have the problem written down. Let's go and write down what we know, though. The circle that has a center of -8, 7, well, we know that's opposite intuition. That's x plus 8 squared plus y minus 7 squared equals, let's say r squared for now. We don't know what's going to go in there. But we do know that it has its center at -8, 7. And when they say tangent to the y-axis, what they're saying is that it's going to barely touch the y-axis, and then it's going to do its continual thing. Right? Looks like my little Death Star right there. So it makes contact right here. I just need to figure out where this point is. What is this point? Well, if it makes contact with the y-axis, it had to travel 8 steps in, which means this is going, and the elevation is going to stay exactly the same if my radius is horizontal. In this case, it is. These coordinates right here are going to be 0, 7. So what I need to do is I need to find the distance between -8, 7 and 0, 7, and that's going to give me my radius. So r equals big square root of -8 minus 0 squared plus 7 minus 7 squared. Well, that's easy. That goes away. That goes away. My distance is 8. So that's my radius right there. So my radius is, or rather r squared, is going to be 64. And that's how you do it. Okay. Hopefully you guys are doing okay. We'll see you next time.